Hello, everybody. Today we're actually going to finish up Unit 2 with multiple angle and product to sum formulas. So first we're going to do a little bit of an investigation. We're actually going to use the sum formulas that we learned in the previous section to derive the double angle identities. So the first one we're going to look at is tangent of 2 theta. And we know that tangent of 2 theta is actually tangent of theta plus theta, where this first one can be your alpha and the second one can be your beta. So we're going to use our identities from yesterday or the day before. So we have tangent of alpha plus beta is equal to tangent of alpha plus tangent of beta all over 1 minus tangent alpha tangent beta. So we're going to use what we just have up here, this theta plus theta. We're going to plug it in. So we have tangent of theta plus tangent of theta all over 1 minus tangent theta times tangent theta. And when we reduce this, we have 2 tangent theta in the top. And that tangent times tangent right here is going to give you tangent squared. So we have 1 minus tangent squared theta. So our first double angle identity is 2 tan of theta over 1 minus tangent theta is equal to 2 tangent of 2 theta. We're going to do the same thing up here for 31. Sine of 2 theta is equal to sine of theta plus theta, where this first theta can be your alpha and the second theta can be your beta. It doesn't really matter here, but for the sake of putting it into our equation from yesterday, we're going to label them. So we know that sine of alpha plus beta is equal to sine of alpha times cosine of beta plus cosine of alpha sine of beta. So we're going to put this in to our equation, and we're going to get sine of theta times cosine of theta plus cosine of theta times sine of theta. And if we rearrange this, we'll have sine of theta, cosine of theta, plus sine of theta, cosine of theta, which means we have 2 sine theta, cosine theta. So this is actually our second double angle identity. And last but certainly not least, we have cosine of 2 theta, which actually gives us a few different identities. So we have cosine of 2 theta is equal to cosine of theta plus theta. This can be your alpha, that can be your beta. So we know that cosine of alpha plus beta is equal to cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. So now we have cosine theta minus sine theta, which will give us cosine squared theta minus sine squared theta. Thing about this one is you can actually rewrite it a few different ways, because we know that cosine squared theta is actually equal to 1 minus sine squared theta. So all we did was we replaced this cosine squared theta here for this guy, which will actually give us 1 minus 2 sine squared theta. And we're not going to just stop there. We're going to find a third way to write this. We can rewrite this negative sine squared theta as 1 minus cosine squared theta. So we have cosine squared theta minus 1 minus cosine squared theta, which gives us cosine squared theta minus 1 plus cosine squared theta. And we're just squeezing it in down here. That's going to give us 2 cosine squared theta minus 1. So as you can see, cosine of 2 theta gives us 3 different formulas. Now, these are just little proofs. I want to show you guys how we got there, okay? These you're going to use. These are all your double angle identities. And what we're going to do first is we're actually going to verify an identity. We have 1 minus cosine of 2x times secant squared x is equal to tangent squared x. Now, that left side is definitely more difficult. So what I'm going to do is I'm actually going to use the double angle formula, double angle identity right here. Now, the question is which one do I want to use? So I know this cosine of 2x is going to be having to multiply by the secant squared x. And I want that secant squared of x to go away. So I know that secant squared and cosine squared would actually cancel each other out. So using that knowledge, I'm actually going to use this second identity. Now, I just want to point out that you can use any of these identities. They'll all eventually give you the correct answer. I'm just going to use this one because I think it's going to give me the quickest route to my answer. Again, any one of these will give you the right answer. It just might take you a little longer. So what I'm going to do is I'm going to replace that cosine of 2x with 2 cosine squared theta, x, because we're dealing with x's, minus 1 times secant squared x is equal to tangent squared x. And that is using the double angle ID. Okay, so the next thing I'm actually going to do is I'm going to distribute the secant in here. So I'm going to bring this 1 down, and now we have 1 minus 2 cosine squared x times secant x. This cosine x and the secant x are actually reciprocals. That's why we chose it. That's actually just going to give me 2. And then we have negative 1 times secant squared x is going to give us negative secant squared x. And that's going to be equal to tangent squared x. Notice here how I kept the parentheses. So all we did here was we distributed. Distribute. We're actually going to distribute again. We're going to distribute that negative sign to both of these guys in here. So now we have 1 minus 2 plus secant squared x is equal to tangent squared x. We distribute it again. Then we're going to simplify here because 1 minus 2 is just negative 1 plus secant squared x is equal to tangent x. And then we know that negative 1 plus secant squared x, that's a Pythagorean identity, and that's actually going to give you tangent squared x. And we are done with that Pythagorean identity. Okay, so the next one we're going to do, we're actually going to use a couple different identities, not just the ones we just learned, but the ones from yesterday and a couple other things. It's a doozy, so buckle up. So we have sine of 3x is equal to 3 sine of x times 4 sine cubed x. So where are we going to start on this one? Even though that right side looks a little tricky, that sine of 3x is actually very difficult. So what we're going to do is we're actually going to break up the sine of 3x because we don't have a triple angle identity to work with. We only have a double identity angle to work with. So what we're going to do is we're actually going to split the sine of 3x up into x plus 2x. Okay, so we just split it up. And then we're going to take that sine of x plus 2x. This will be our alpha, that will be our beta, and we're going to use the sum formula in order to split this apart. So that's actually going to give us sine of x times cosine of 2x plus cosine of x times sine of 2x. So this is our sum formula, learned on Tuesday, or 2 days ago, or yesterday, depending on when you're watching this. So what we're going to do now is we're going to use the double angle formulas to get rid of this cosine of 2x and sine of 2x. So I realize here that I have a lot of sines going on, and I'm going to need a sine cube somewhere. So what I want to do is I'm actually going to turn this cosine of 2x into 1 minus 2 sine squared x, which is the third one right here. Again, you can use any of these and get to the correct answer. It just might take you a little longer. So then I'm going to have sine of x, and then I'm going to do 1 minus 2 sine squared x. And then I have my plus cosine x. And there's really no options for the sine of 2x. There's only one thing, which kind of makes it a little bit easier. We have sine x cosine x. And again, we use the double angle formula here. Okay, so now we're going to start moving some things around and distributing. I'm going to take this sine, I'm going to distribute it in here. So that's going to give me sine of x minus 2, and then sine of x times sine squared x is going to be our sine cubed x. And then we have over here we're going to distribute this in here. So we're going to have 2 sine x times cosine squared x. And all we did here was we distributed. Okay. So we're getting close. If you guys look at our formula up here, you'll notice that there's only sine. So we need to get rid of that one cosine because that's going to be a little bit of a problem. Okay, so what we're going to do is we're going to use Pythagorean identity. And I know this is a little bit long, guys, but stick with me here. This right here, this cosine is going to turn into 1 minus sine squared x using a Pythagorean identity. Okay, and then we're going to distribute this in again. So now we have sine of x minus 2 sine cubed x plus 2 sine of x minus 2 sine cubed x. So all we did here is distribute, and then now we're just going to combine like terms. This sine of x and this 2 sine of x become 3 sine of x, and then this negative 2 cubed x and this negative 2 cubed x becomes negative 4 sine cubed x. And that's what we had originally. And we are done. So I know that one was a little bit of a doozy. They're not all going to be like that. So what we can also do is we can actually solve over the interval within the unit circle. So we have in 35, 1 minus cosine of 2x is equal to sine of x. So I already have a sine of x, so I think it's easier to continue using sines of x's here. So when we do our double angle formula, we're going to turn this cosine of 2x into 1 minus 2 sine of x. And then sine squared x. And then that way we only have sine of x's from here on out. Okay, so now I'm going to distribute this negative sign to both of these. So I have 1 minus 1 plus 2 sine squared x is equal to sine of x. And you guys should see that those ones cancel out. So now I have 2 sine squared x is equal to sine of x. Now, be really careful here. A lot of kids would divide both sides by sine, but if you do that, you're actually going to be missing out on an answer. So what I'm actually going to do is I'm going to subtract sine for both sides. So now I have 2 sine squared x minus sine of x is equal to 0. There's a sine in both of these terms, so I'm going to factor that out. So I have sine of x is equal to 2 sine of x minus 1 is equal to 0. We're going to use our favorite property here, the zero product property. So we have sine of x is equal to 0 and 2 sine of x minus 1 is equal to 0. So we already know here that sine of x is equal to 0, 2 different spots on the unit circle. Please notice that we are using radians here, so your answer should be in radians. So x is going to be equal to 0 and pi on the unit circle. And then we're going to solve over here. We have 2 sine x minus 1 is equal to 0. We're going to add 1 to both sides. So we get 2 sine of x is equal to 1. Divide both sides by 2. So we get sine of x is equal to positive 1/2. If we go back to the unit circle, we have that x is equal to pi over 6 and 5 pi over 6. So here are your 4 answers. Now I just want to point out that if you had just divided both sides by sine, you would have actually missed out on these 2 answers right here. You would not have had the full answer. So let's do one more here on these, and we're going to do 2 cosine of x plus sine of 2x is equal to 0. So again, I have a cosine here, and there's really only one thing we can do with the sine of 2x. We have 2 cosine of x plus 2 sine of x times cosine of x is equal to 0. Both of these terms have a 2 cosine x. So what I'm going to do is I'm actually going to factor that out. So now we have 2 cosine of x times 1 plus sine of x is equal to 0. Using our favorite property again, we're going to split that up. We have 2 cosine of x is equal to 0. 1 plus sine of x is equal to 0. I'm going to divide both sides by 2 here, and I get cosine of x is equal to 0. Cosine of x is equal to 0 2 times on the unit circle, and that is at x is equal to pi over 2 radians and 3 pi over 2 radians. Over here, we're going to subtract 1 from both sides, so we get sine of x is equal to negative 1, and x's sine is only equal to negative 1 once on the unit circle, and that is x is equal to 3 pi over 2. Now, you guys will notice that these answers repeat. If you were giving me the answer, you would only have to give them once. That is actually the end of our lesson and the end of the unit. As always, I will be available in the Google Meet. I can help you answer any question that you might have. A lot of kids have been chilling with me in the Google Meet recently because I know it's been difficult, and they found it much easier to just ask questions. You don't have to be there the entire time. You can turn off your stuff and only turn on your mic when you have questions. So come on and see me there, or you guys can chat with me through GoGuardian or send me an email. I hope you guys have a fantastic day.